Hello everyone! Today in this video we are finally going to be applying some of the trig knowledge that we have learned over this course to problem solving. So the first kind of problem solving is going to be the most basic problem solving. It will be even available in the core maths IGCSE syllabus, but then anyway, you got to start somewhere. So this kind of problem solving will focus on two types of problems: finding any side from one length and one angle. And the second type of problem will be finding any angle from two lengths. And this is all when applied to a right-angled triangle, or RATs. I don't think anyone actually calls them that, but that's just something I came up with on the spot, so please forgive me. Say we have this triangle here, and it is a triangle with side lengths of perhaps 7, 13, and 12. Like, I know this is going to be a valid right-angled triangle, so you can check that yourself with the Pythagorean theorem, but anyway. Oh, no, this is 5, 13, and 12. Yes, so what we're going to do here is we're going to first address the second type of problem. So, like, say we want to find this angle theta, and perhaps we only know those two sides, 5 and 12. Well, 5 and 12 are the opposite and adjacent sides to theta, so we know O and A. And what trig function relates O and A? And that's actually tangent. So we know that tan theta must be equal to the opposite over the adjacent, or 5 over 12. And so what we can do now is we can use the inverse trig function, tangent -1 of both sides, to find that the angle here is going to be tangent -1. On your calculators, normally tangent will be shift and then, or inverse tangent will be shift and then the tangent button. So tan -1, 5 divided by 12. That's going to give us an angle of 0.395 radians. When rounded to 3 decimal places, or alternatively, it's going to give us I'm just going to work it out here. I'm going to set my calculator into degrees. It's going to give us 22.6 degrees. Alright, so something like that is how you would find this angle from two lengths. If you had to find the other angle, for example, the opposite would be 12 and the adjacent would be 5. So you just take tangent -1 of 12 over 5. And so on and so forth. You first have to find the appropriate trig ratio to use, and then you can take the inverse function of some ratio of the two sides you know. And now we are going to look at the first kind of problem, which is finding any side from one length and one angle. So say we have this triangle here. Or in fact, let's make it a real-world problem. The most famous kind of trig problem that they introduce new students to is the brick wall here and a ladder. And the ladder is leaning against the brick wall at an angle of, say, 25 degrees. So it's actually, this is not to scale. Let's make this like 65 degrees. The ladder is leaning against the wall at an angle of 65 degrees. And as well as that, we know that the ladder is 10 meters. And a question would be something like, what is this length here? How high is the ladder up the wall? So you could use the information that you want to find something related to the opposite and the hypotenuse, because the side length you know already is the hypotenuse of this right angle triangle, and the side length you're trying to find is the the opposite side length to that angle that we know, angle 65. So what we're going to know here, let's name this side O because it's the opposite. We're going to take that sine of 65 is going to be the opposite over hypotenuse, or rather O over 10 meters. And therefore, if sine 65 is O over 10 meters, if we multiply both sides by 10 meters, we get 10 meters times sine 65 is going to be O. Or if you want to put this into your calculator, and this is the letter O, not the number 0, you will find that such a side length is going to be 10 times sine 65, 9.06 meters when rounded to 2 decimal places. Alright, so I hope I've given you a firm enough grasp on how to do these kinds of questions. Hopefully you'll be able to learn something new from this. So yeah, thanks for watching. Basically, what you need to do for this one is to put it into form so that, like, you take the trig function, you figure out what it explicitly means, like cosine is the adjacent over the hypotenuse, and you substitute in whatever length you know already, and then you solve the equation for whatever length you don't know yet. So like, looking at this triangle here, say you know the hypotenuse is 12, you know this angle is 30 degrees. Now, what do? Cosine, or rather, let's try and find this angle here, and cosine is going to be the adjacent over hypotenuse, so the adjacent over 12 is cosine 30, and therefore 12 cosine 30 is the adjacent. You can do that if you want, that's an exercise for you. And yeah, so that's how you would find some lengths of a right angle triangle that you don't know before using the trigonometry functions that you learned about now. Alright, so in the next video we're going to be covering how in further pure math we often have to do these kinds of trig operations with shapes in 3D like pyramids and cones and stuff, and I'm going to be talking about ways to do that. Alright, so thanks for watching.